now we're going to, I guess, switch gears a little bit, but not completely, and think about the integers and how we would teach arithmetic for the first time. I mentioned this later in the book, but I'll start with it now. When I think about different levels of understanding, or different ways of understanding, when it comes to math at least, I have an intuitive side where you play with objects and you get a sense for how numbers work. And that's very much how we teach little kids. 1 plus 1 is 2 and things like that, because they can see the objects and they count them. There's nothing fancier involved. And working with numbers can be very intuitive. And we're going to stay on this side for now, because we're working with small numbers, simple concepts of basic arithmetic. It's definitely very reasonable to hang out on this side when you're introducing a concept like that for the first time, thinking now as a teacher. Eventually, as the numbers get bigger and the concepts get more complicated, we'll be sort of forced to drift over where our intuitive reasoning and understanding falls short a little bit, because the concept is too complicated, or the numbers are too big, or something. I can't count little objects anymore. Then it doesn't make sense to stay fixed on the left side, because it's not enough. And you have to really explore mathematically what does the concept really mean. So I never really know what to call this other side, but I think in the book I called it just mathematical understanding, I guess. Well, I already said understanding. And by that I just mean that we have to look at what, for example, addition or something simple, what it actually means and what are the properties associated with that, giving us shortcuts to perform calculations. When the numbers are small, we don't need any formulas, we don't need anything. Our intuition is more than sufficient. But as things get more complicated for various reasons, we have to be able to move to another level of understanding that would allow us to be more efficient and work with and use those things to solve problems. But for now, we're going to stay on this side, because little Timmy doesn't know anywhere else. It is definitely a reasonable place to start. So let's just label the kinds of numbers that we're going to work with. The concept of counting, I have 1 chicken, and then I have 2 chickens, and 3 chickens, and so on. That is a very natural, intuitive concept that all civilizations share, regardless of how they count and how they write their numbers. The idea of counting is very intuitive. And initially the idea of not having anything, needing a number to represent nothingness, wasn't really required. They didn't feel that it was necessary to have a symbol to represent that. But eventually, as civilizations grew, they added that thanks to the development in India, and the symbol 0 came along. So here we have our natural numbers. For obvious reasons, because they occur naturally. I have objects, and I'm counting objects. It just makes sense. We're going to give them the name and end with a double line. It's really just for information's sake. We're not actually using those names, but you might see them in the future somewhere, so it's good to at least see the symbol once. The natural numbers. So if we take these, again, now trading and things like that occur more often as my civilization grows. And maybe there's a promise of some chickens to someone else in trade for something else. Or I could owe someone chickens. And these numbers don't necessarily reflect me owing something to you. I actually have less than 0 chickens because I still owe you a chicken. And with that, the negative integers came to be, to represent those concepts. When you are trying to do some sort of accounting, you need the other side of having something, which is owing something. So eventually, that was a fairly natural extension of the natural numbers as well, and we'll call these the integers. And for some reason, the letter is Z with an extra line. So the idea of whole numbers, as they're introduced in elementary school, is kind of nonsense. I don't know why they use whole numbers instead of natural numbers. There is no such thing in mathematics as a whole number. It's made up to make things even more intuitive for reasons I do not understand. You really only have the integers. You can section this off by saying, okay, here we have the positive integers. Here we have the negative integers. And if you want to include 0, you usually do it with the positives, and you can call them the natural numbers. Outside of that, there's nothing else needed. Yet they introduce new words to kids for absolutely no reason whatsoever that I can see. So we're now on the intuitive side. I want to work with the integers because they include the natural numbers. And a reasonable, intuitive representation of the integers is on a number line, wobbly as it may be, where at some point I have a 0, and it keeps going on forever, right? That's extremely wobbly wobbly. It's not really better, but it will. Then I have a 1, and a 2, and a 3, and as many as I need. Let's just fill the space here. Not sure how many I'll need. I want 10, please. 10 would be nice. But of course, I can go on forever. And then, of course, to the other side will be my negative integers. So it's all very intuitive. I have to switch this. It keeps slipping. Let's try this one. Ooh, so much better. Very intuitive still, nothing to it. Can I make it to -10? Yes, I can. You can extend that however far you want. So now we can use this visualization by way of the number line to introduce basic arithmetic to little Timmy. And we start with addition and subtraction. And we can give little Timmy intuitive rules, well, some of them are intuitive, at least to start with. Intuitive rules or a method to travel along this number line to get to the answer that I'm looking for. So if I have my example up here, let's say 3 plus 2. Now remember, to us 3 plus 2 is worse than trivial. You don't even give it a moment's thought. But to someone that is barely counting for a little while, addition is a new concept, and it's hard to appreciate the struggle going into 3 plus 2. Some of that I've seen firsthand, and it's hard to really relate to that when we're so used to it. It's just a matter of time. But in the beginning, it's new. So how can I explain to little Timmy what to do to calculate that using my number line? I can say, little Timmy, well, stand over here. There you are. You're doing math. You're happy. Big smile. Looks like he has a boat, I don't know, something. Stand at the first number and I'm going to add. Adding makes something bigger, so I'm going to look to the right, because that's where the bigger numbers live. Now I'm going to use the second number to tell me how many steps I should take. I'm going to take 2 steps, and that is going to be my answer. Something simple to us is not simple to little Timmy. And we have to, I wouldn't say dumb it down, but go really basic when it's the first brand new concept that your audience is getting. So that's the basic sense. It's intuitive, the basic kind of arithmetic calculation. It's intuitive to use the number line. No one's going to question that. Yeah, I want to make it bigger. How much bigger? 2 steps bigger. No problem. Then I can have 3 minus 2 as the next intuitive calculation that I would have to perform. Now, of course, we're using very small numbers, but and I can visualize these in my head because I can keep track of around 7 to 8 things very easily without writing it down. But as the numbers get bigger, now my reliance on the number system will increase a little bit. So we could easily make this like a 19 plus 2, and suddenly it's not as easy as these numbers, though the number line method doesn't change at all. So I'm just using these to introduce the method. It doesn't matter. You can shift along the number line wherever you want. So the number line is really useful for that. Very useful. And I've done that. I've tried with my 5-6-year-old. Start small, because they always want to start the number line at 0. And then getting them to understand that you don't have to start here. There is no start. Whatever the first number is, just mark that off and numbers around it. You can shift wherever you want. And the number line is really useful for that. Things that we take for granted, we don't even think about that. Of course you can shift. But to them it's a bit of a jump to not feel tied down to 0. So I start at the first number. There I am. Now I'm going to subtract. Subtracting makes less. So I'm going to look, still smiling, still doing math. I'm going to look to the left because I'm subtracting. Now the second number tells me how many steps do I take. I take 2 steps, and there is my answer. Again, my goal isn't to bore you with things that we can do. It's, if my intention, if my plan for the future is to go into education, you could get a grade where these are the things you have to do. And we can't just say, well, tell me why 3 plus 2 is 5. Why don't you just understand that? Because to him it's brand new and it's not that easy. So I have to have knowledge of an intuitive method, and we're going to do 2 of them, to help them get used to this. And the number line method is, I feel, my favorite. Yeah. But there are others, of course. Now you can say, yes, okay, I'm not tied down to anything. Wherever the first number is, I start my number line there and pick those numbers. So it can be big, it can be over here. I can have -8 plus 2. Doesn't change a thing. So in that sense, the number line is really useful, that this seemingly is much more complicated, but the number line is exactly the same. Exactly the same. I stand at the first number, I look to the right because of addition. How many steps do I take? 2, and it's no problem. And these 2 are very different in terms of difficulty for little Timmy, but the method's exactly the same. So we are taking that intuitive 3 plus 2 method and extending it to any position, any number that I'm adding. But then the obvious issue is, well, what if I'm adding some of these guys? Now simply to distinguish between the operation, which is addition, and the negative in front of the names, or in the names of these numbers, I'm going to put the negative just a little higher, just to tell them apart. It's not a good idea to put them in the same line unless you use brackets. It's going to confuse me completely. That's become standard in books to just use it as a subscript, as a superscript, instead of on the same level, to be able to spot this is the name of the number, that is what I'm doing. Okay, so my method should be fairly similar. I'm only extending what I've built so far. So I'm standing at the first number, I'm going to add. Adding has every intention of making more, so I'm looking to the right. Now I have to look at this second number. If it was a 2 that I'm adding, I am walking forward, forward being right. But negative 2 is very much the opposite of 2 in the addition sense on this number line. So I should do the opposite, which means walk backwards 2 steps, putting me at my answer. So again, adding positive integers versus adding negative integers, it is a step forward. It is a little less intuitive, but our basic intuitive method can be easily adjusted to help Timmy find the answers to that, even though this is intuitively a more difficult concept than this. I have 3 chickens, I owe you 2. How many chickens do I really have? Only 1. But as the numbers get bigger, it's a little more confusing. Last one. If I subtract a negative number. So how do I adjust my basic intuitive number line walking method? Well, I stand at the first one. Stand at the first number. Subtracting is aiming to make less, so I'm going to look this way. It's not quite clear. Timmy is looking this way. See, his mouth is a little more straight, so he's becoming a little concerned about the intuitiveness of this method. But he's still hanging in there. He's looking left because of this subtraction. Now normally 3 minus 2 would tell him walk forward according to how you're facing 2 steps. But I have to now do the opposite of that, so I'm walking backwards 2 steps to end up at my answer. And yes, we know 3 minus negative 2 is 5, but Timmy has no idea of that. We have to give him the tools to figure that out initially when it's brand new. Any questions on the 4 variations and how to use the number line? So you have to make sure that your little diagram, you're showing which way it's facing, which way it's walking, because you have to try and explain that you understand how to use the number line. Any questions? So I'm looking at chapter 12 at the top of the next page. That's the steps for how to do this are written out there in case you missed something. We're going to do exercise 12, but just to prepare for the next one, everyone, or I guess every table, I think every one can take around 10 of these tokens, 10 to 12, if you feel greedy. I think we can get away with 12, just in preparation for the next bit. You can save time while we're doing the exercise. You can share it on your table, or you can have your own if you don't like to share. I think there's enough for 12 per person. So So let me emphasize again, this is not about performing the calculation. I can probably teach a monkey to do it. Well, not me personally, but one probably can. That's not the point. The point is, can you explain to someone that's seeing this for the very first time how to do it? So your answer has to reflect that you understand how to use the number line, not the answer. Yes, the answer matters, of course, but how you get there is much more important right now. So exercise 12.1, I'm performing some of the 4 variations that I can see. We've done 3 plus 2. Oh, that was a total coincidence. Total coincidence. Let's make that a little more interesting then. I didn't even see that one. Maybe subconsciously I did. Let's go -2 plus 4. Just to mix it up, I've done that one. How do I use the number line? First step, the first number tells me where to stand. The operation is addition. Addition makes bigger, or tries to, so I'm going to look to the right. Then from my perspective, forward is right, backwards is left, from where I'm looking, or how I'm standing. I'm taking 4 steps forward, and my answer is over there. So it's not hard to verify that you find the right answer. The question is how? How? Any questions on the how? It looks simple, but to the right audience, it is not simple at all. And it takes practice. You have to know your audience. 1 plus -4. So again, I'm standing on the first number position. I'm going to add, so I'm looking to the right, which is then my forward direction. Normally I would take 4 steps forward, but I have to do the opposite, which is 4 steps back. And there's my answer. So you do these a few times, it's really not a problem. Questions, comments? Let's do 3 over here. What is 3? 3 minus 5. You can test it out if you haven't come across it yet. Try and explain this to a 6-year-old, it does not go well. Unless they're really just naturally advanced, right? In general. It's not an easy sell. The basic ones are. It's not so easy. So, let me make some space here. 3. And I'm subtracting, so I'm looking left. How many steps am I taking in my forward direction? 1, 2, 3, 4, 5. And there's your answer. Last one, 4 minus -2. Now I'm not saying introduce all of these negative integers and everything at once. It's a slow process. You start with just plus, and then introduce a minus, all just in the natural numbers. And much later do you go in over in the negative integers. Though in my opinion it should be done sooner than it currently is, because the longer you wait, the more you make kids believe that this is it. There are no other numbers. And then when you introduce other numbers, they're much more resistant. Just do it all in sort of one go, let them progress through it, of course. it doesn't feel as far. But the way things are placed, this feels much more foreign than it needs to. Anyway. Stand at the first number. I am looking left because I'm subtracting. Let me show which way I'm looking just in case my face isn't obvious. Then I am taking 2 steps backwards because it's the opposite of 2 steps forward. Positive 2 would mean 2 steps forward. So the opposite is negative 2, which means 2 steps back. Questions and comments on this? Yes?
Would you, I guess, show this to them with rules and like just state the rules?
No, because I wouldn't, because it makes, as a kid, you don't like rules. You don't want to be told what to do. But just by example,
just go over
the rules will establish themselves naturally. You do enough repetition. Of course, you're talking through this, right? Until they can do it themselves through those steps, and without you calling it a rule, it's already done. If you tell them, no, it's not going to go well. In general, of course, there are some. Like my 4-year-old, you tell her, write a line, and then a little tummy, and she does exactly that. No questions, nothing. But not everyone's like that. Then maybe she won't be for long. So, in general, no, don't make rules, or don't make them seem like rules. That's it. You are following rules. You're following a recipe for how to get it. Of course, you have to. Any other questions, comments? Oh, does everyone have some tips?
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.